5. Okay. 5. You are told find the height. Okay. Find the height of water. So this is one. So this is bottom up. Okay. So now you will be wrong. You are given right. Yeah. 9 meter, 18 mm. Okay. What is very thin? Okay. 5% plus we actually say the plane stress. R0 open end. Okay, plus sigma L. So all this is 1. Now it is a vertical one, like this direction. Inside pressure, the intention. That's all. Okay, 1 T.
What?
Alright lah. Then, they give you safety factor lah. Okay, so
5.
now it doesn't. Now they know it's 1 D. New criteria is irrelevant in the one. Okay, third question. Okay, I missed the other one. Okay, the third. Let me go through the indicator. Not always all present. This one has all the three. One strain gauge. Next. No last one. The last one. No new criteria. And yet they make you find safety factor, right? Whatever. You have that, right? Because so guys, if you safety factor of the thing last week, you don't have last week. Okay, 3 indications lah. The new criteria is a bit subtle. Or you miss one indicator, you still see the other two. It's a very opposite. Okay, so new criteria irrelevant. So you can use anyone to use practice. Okay. The plane intention 200. So guys, use sigma gauge sigma p, sigma p, and so you have use stress 200 intention. Factor oil lubrication, flammable, inflammable. Okay, this is probably some of the cover how can flammable thing they will cover it. Because you open up to show you. Okay?
40.
40. Okay. Then this one. So guys, now I don't care what happens to the L. Sigma H formula always true one. So guys, you can say sigma H is equal to formula H is 2. So guys, from here you will get your E. From here you will get 16 guys, 16 meters. These are those Jurong Island huge one. Just to maybe appreciate what is going on, guys. Do you know what's on an island? Do you know what's on an island?
What? Sentosa aja.
Sentosa.
Island what?
Jurong Island.
Oh.
When Jurong Island is new, okay, we bring students there. The time of there, then comes September 11. Masa masih boleh, they allow this So guys, all dangerous now, man. Okay, see, right? So guys, your pass through the you guys, you have to go here, pass through here. You don't have to do what carry up. No, so that actually they connect a pipe. This guy on the power here, they actually connect a pipe. So they have piping system, okay? So guys, all you gotta do is this guy you connect up, then you pump. Then after how you think you really ask the doctor to climb 16 okay? You know that's what why I'm saying that when we bring to IGP this guy must not be an engineer, no serious. He says, so what is the ladder for? You see the ladder outside. So the ladder for the worker climb and pour it very loud. Okay? So guys, it's for maintenance lah. Painting whatever else you have to do it. You know that, you just pump. But how do you know it's full? I think you know the system. That's why it's not pressurized.
Sensor.
It never pressurized sensor, okay? It's just pump, go higher. Okay? Right? Float, guys. It's like your toilet. Okay? So the blood after you flush, you fill up by yourself, and you stop by the overflow slick. Okay? So guys, the flow will go up, and once you reach the level, you will trigger a switch. Close the valve, stop. Don't pump it anymore. Okay? That's like a toilet system. Okay? So actually very nice and an island, really any terrorists attack whatever, or less natural, so accident, let's say, fire. Okay guys, we got an island, explosion, people are very scary. Okay, we got an island, security is easy. How to assess, guys, if you want to sabotage whatever? It's very hard to protect something that is installed on a building. Okay, no way you can come back by the sea or so. Okay, so for this is okay, so that's the system. Alright? Okay, so now after this is easy, right? Next, so we're gonna height of water, we draw the element. We draw the element, we're gonna height of the last one. Expected reading, this one chicken. Guys, 1G. Partial ratio. Okay, that is your expected strength. Any question?
No.
Before you do the last one?
No.
Because next week is lab and the following week must do tutorial 5. Okay. So guys, I try one more for you. No problem. Tutorial 4 you can see your time. Cover it up. Okay, let's do one more. That is the push problem. Many students last week they don't understand what is going on. Okay, actually it's a very tricky problem, but people that don't know what is going on. Okay. I was telling them DME, don't do a DME, all these engineering component you must know there, if you don't know, you have seen less things, they need more. They come up to this you do this
What?
some of them cannot visualize this. Guys, look at this one. This is a push. First of all, why do you need a push? Okay, what is a push for? It's not the push you see in the garden. This is the mechanical component. Push. What is the push for?
Bush is a glass.
So guys, this is a blade. This is a bolt. They never see what mechanism this is. Most of you haven't done army. When you go to army, you have to handle a rifle, straight. There is part. This hole is very small. That is how you fire. You guys, when the powder fire powder, okay, you actually push a pin. Okay. Okay, high pressure, you push it. You must drag the pin so that you can. And you go, and you go. It's very high velocity because of the gunpowder. So you hit the bullet at a very high speed. It's a general, okay? Only the bullet hit. Okay, guys, the bullet hit, the power is inside. Okay, so the pin edging. Okay, so it's a guided. So it's maybe, I don't know what mechanism is. Maybe there's a pin going through. So guys, mechanism work like that. Very soon you will wear out. Okay, and these are very, very corrosion resistant material. When it comes to corrosion, it must be some air oil. I think you can know it very well. Air material. Okay. Pure material, copper, whatever. No, it is normally not that corrosion. It has to be some air oil. I think so that you use bronze. Okay. Then why don't you okay? Then the whole big use bronze. Guys, bronze is like say, let's say I make 1,000 pieces. And you waste so much. How you want to make this one bronze or why? The only problem is part of the complexity. Okay? So this one like that is just to collect that area to push. That's all. Question is how do you assemble this, guys? How do you put the two parts together? You cannot just throw it in and it will drop out. No? It must be secure. How do you secure push? Okay, to the door. Yes. See. Okay. Well, bronze. Mostly okay with bronze. When you have two different material, guys, welding may not be good. You have seen this component many times, okay? How is it done? That's why the DNB last week, so you use screws like that. Ever see that? No, right? Guys, that's why once you understand the assembly process, you will know how to do this. That's all I'm explaining now. Okay, so just highlight this up. Okay, then I'll just write a step, that's it, okay? Like that, we cover more ground. So, what I'm asking you is, you have. So, guys, every unit, you will see, like unit 3, is everyone a transmission shaft? No. Okay, some people number 4, number 3 is just a post, doesn't transmit power by the same poster. So now this one is not a pressure vessel, okay? But it is under pressure, so you can do the same. Same thing, unit 5 we are doing. There are some they are not here, not structured here, but they are the same work. So every unit has this. We are asking you this. Okay? So guys, we have two components lah. Push, okay, this bronze, okay, then we have another component, this, and you have the plate, okay, so maybe mouse here okay, subjected to wear. That's why you need a bronze to play it. Okay? You are told, guys, the bronze bush, inner, outer. Okay? So guys, to make this guy okay, normally they will have this here. Okay, you can say, oh, what going on? 31, then go in. Okay, you will slip up. Okay, what they normally do is 9, 1.9, now these are the things that are tables to check. Okay, so let's say just a bit smaller. Just a why, guys, I think because bronze is cut. Okay, bronze is cut. If you brittle, that's why for this reason there's no brittle cushion. Okay, so if you put in this brittle, then the bronze cushion crack, so it just crack. Okay. In the case of really brittle, let's say something you can brittle. What do you do? There are two ways. Okay, so either you force fit. Force fit is only for tangkap. One more time, we will not test it. Guys, olden days, this is called, remember, mechanics of material. It is closer to your material. Let me explain that. Last time really as a student to know, if this force fit, how can you brittle? So they will know if you use like those days. Now it is illegal already lah. Okay? So guys, if it's brittle, what do you do? You cannot force it.
Yeah.
What do you do?
They make that one bigger.
Guys, we will keep this one. Okay. Question. When you keep this one, okay, does the hole get bigger or smaller?
Bigger.
Bigger, right? Some jokers say it's smaller.
That one joker.
It's an easy student, horrible. Okay, guys. We have evening students. Evening students have no problem. They have done all this. They are working. You know what I said? How do you visualize the whole smaller? So we need things expand as that. So expand out. So expand. It expands inwards. What is wrong with this thinking?
Naive.
Okay. So let's say you are the lecturer, and the student says expand inwards, not expand. So the whole gets smaller. What is wrong with this thinking? You know what I tell you at first, okay? If I have a pinhole, very small hole, then I hit, and the hole goes up, no hole, is it? Okay, that made it ridiculous. But really, you have to argue it up mechanically. What is wrong with this thinking? See? When you talk about changes in length, guys, must be solid. Look at this. We are changing the diameter, okay, guys? You are using heat to change it. There's one thing that is not in the syllabus, it's called thermal stress. You need something to change. Okay? That one is danger, it's not in the syllabus. You must talk about the coefficient of expansion of this. That's what you don't know, okay? So guys, it must be solid, right? Okay. This guy is actually doing this. He's actually saying this. So guys, when you settle the data direction, you flow in the cannot, but this guy is not solid. You must go for a solid angle. A solid bar, I need a cost angle. So guys, the best way to confirm somebody who thinks the hole is solid is go for the circumference. Guys, you hit circumference solid, right? So this circumference will grow longer. The hole bigger. So guys, see all this stuff, whenever it is this stuff, it can be very confusing. You always go for a solid thing. If the circumference must be longer, sure, okay. Alright, so guys, if it's brittle, you hit, then you have to whack it in. And this guy, maybe will go from 29 to 30.1. Then you just drop it in. Okay, and then it cool. And then cool you.
Expand.
Okay, so guys, this is called pressure. Okay, so guys, we are not doing the plate. So after the whole assembly is over, external pressure. Any question? That's all I want to highlight. So once you understand the system, then it will relieve. Any question? Guys? So under this pressure come from how much smaller you make the hole, 29.9. This one we don't do like in the syllabus. Okay, so from there you get the pressure. So we give you the pressure. This stuff they come out, they will give you the pressure. pressure is given to be 10. Okay? So 10 here lah. Okay. After that, bring in size. Question. What do you think? This is the most common mistake. This thing. 2.
That should be
Just
2.
the mistake I was talking about. Up again.
The tick.
So many children will do it as 2. Up again. Important. So good. Ever mistake, then make it down there, you don't make mistake.
1.5.
Guys,
1.9.
guys, big diameter minus 1 millimeter is twice thickness of it.
4. Twice of that.
The difference is 2.
2.
2 thickness is 2, you know.
Ah.
So what?
Oh, divide by 2.
4 radius. So many children just take the difference. Remember, the difference in diameter is twice this. Big T minus 1 is 2T, okay? And some students don't care. Guys, sometimes you do that, you end up with 1 and 5%. They don't care because they don't care. They don't even check the TD every time you just like that. And how you think, well, must be big. Okay? So guys, the next question is so many children are this one. Use inner or outer?
Outer. Outer.
I mentioned this actually in the very first day. What is thin wall? So the question is what use 28 on the 30. Then once you learn ask, so use the average 29. Okay guys, what's your answer? I want to go to this and then you can fill up the spreadsheet. Yes. What's the meaning of thin wall, guys? Thin wall means thin wall means we don't distinguish them anymore. We don't want to say the size is big T, small t. We used to use T already. Let me do the diameter, guys. Let me just say that. So that it doesn't end. Okay, if you do this, you don't believe you try, you will get that. That is, okay? That is. Oh, now for the hook stress of it, guys. Now, hook stress, can I draw an element here? Something. So why you do the inside outside? Guys, inside outside no longer relevant. I can put inside by the same, okay?
Hah?
Dari mana? Hook is this way, right? Hook. External pressure, right? Okay, this one is what is sigma L? Sigma L will be like
L shape.
element.
Yeah.
So L, and I use half sigma H to open and close it.
Close. Open.
Some students thought there's an axial force, so you press it. Yeah, after fitting, I took away the press. So the force is no longer being applied. Okay? After the assembly, there's no axial force. It's open and there is a hole. You must drop it in and then the pin will, the operation of the mechanism, how can be closed? Okay? So again, guys, and you see my hand zero. So it might be one more time. If you can't argue all this, I'm not very familiar. One more time. What are the implications? Telling you, let's say you can't argue over it. One more time, guys, what are the implications?
Compression.
What are the question? I just went through this. I must go through one more time. Just now.
Compression.
Yeah, good. No Poisson ratio. You see that? Proportion ratio is irrelevant. Is it okay?
Yeah.
Again, when this question came out that year, quite okay. Then the other one. This is no strain gauge lah. This is no strain gauge lah.
No strain gauge.
If it's strain gauge, there should be one. Okay. Anything else? No new criteria.
No new criterion.
Okay. One more time. Those days can be tricky. Of course, we expect olden days, we expect students to know bronze in Qatar. Now those completely, so we will make it clear to you. Never say, okay, so guys, it doesn't matter anymore. So it has to be, okay, G. Okay. So guys, having said this, be consistent, manage to do this, okay? Say no, I answer it different, whatever. So this part of course all the same. Now, if you this formula is of course guys, you use 28, you use 30, you get different figures, right? So guys, be consistent. Some students part A, part A, use 28, part B, use 30. You switch around, of course. Once you use 28, only 30 must be consistent. What happened is the marker, this type of question, the marker has two sets of answers. When the student choose 28, ABCD like that. Choose 30, ABCD. But you switch around with the minus and must be consistent.
So you,
The difference is very small, within 5% difference.
well,
So if you guys the answers given here, I do not okay, whether they use 28 or 30, but if your answer deviates within 5%, correct, they must have used the other. I think last week we checked, they used the inside. Is it okay, guys? It doesn't matter on both of them. That is why we call it deep, we don't distinguish. The question is management. So they find this question so tricky. How do they give us T and D? Guys, the dimensions are always given, the way things are fabricated. FYP, you want to make this push, you get a drawing, send outside. Do you indicate T and D? No, right. You will indicate in engineering drawing, the ID, correct. So, okay, machine component is like that. So, the data given to you, not tricking you, this part of the data is always given in engineering drawing. It's up to you. Okay. Okay, so once you know this guy, last one, okay, area of ball. Okay. Area of ball, I think the rest you can do, right? This hole, what is the area of this hole? Come to the cell, what is ball? What is the hole there? It's important in assembly. So guys, you did 28. It was 28 before you assemble. Then when you assemble the pressure, it's going to drop, right? Right up. It's smaller. So maybe it's 27.9 or I don't know. Okay? So guys, mechanism, you must always check the volumes. For the pin to slide through, there must be some clearance. If this pressure is too big, this guy's shooting. Then the pin will get checked. You must get the clearance. So it's something you have to check. Okay, after you assemble, you must check all this out. Okay, assembly, normally tolerance, all this must be. Okay, so you must check it. So guys, check it. So guys, this area, how do you get this? Let's say the fire pin, rifle, pressure. Okay, the force pushing the bullet up is pressure times area norm. So how much force you get after assembly? All this. Guys, what is this? So one more time, whenever you change area, guys, it's always sum of two straight times area. This area is of course R equals 1 is square. Okay, guys, this is volume of the sum of two straight. It's a fixed thing. The question to ask yourself is, what are these two straight? Which two straight is this? Okay. Let's go to this one. This area is defined by which two dimensions? It is D and D, it is formula D and D. So that is D defined by these two dimensions. Right?
Yeah.
If it's a rectangle, it will be different. It's a circle, so B and B. So then what string do you use to measure B? Okay. Cross must be solid length. What is that? So that's what we actually do. Okay, I think this will be covered more. So guys, what to fill up? Next week we're going to have, okay, try and finish it. Cannot, you must do it the following week so that I can give you back everything. Alright, then we come back to tutorial again. If you still have question with tutorial 3, tutorial 4, I'll answer before I do tutorial. Please watch that blog whether the